Hey guys, so we can calculate density at home using a load of really basic equipment that you can find normally in your kitchen. Well, I could anyway. So what we need to first of all know that density, the equation for density is mass divided by volume. The units of density are kilograms per meter cubed. Now, this is a really useful way of remembering the equation. Density is shown by not a pound sign, by this rho symbol. It looks like a P, but it's not. So we have density equals mass divided by volume, and the units of mass are kilograms and the units of volume are meters cubed. So if we remember kilogram divided by meters cubed, kilograms divided by meters cubed, it's an useful way of remembering the equation for it. I've written down some useful conversions here. 1 milliliter of water or liquid is the same as 1 centimeter cubed. And 1 million centimeters cubed is the same as 1 meter cubed of water. So, or a liquid. For this example, we're going to use water. Now, calculating a volume is quite easy if you've got a cube, because you just do base times height times width. Now, where it gets slightly more confusing or slightly more difficult is when you've got an irregular shaped object, and this is one of the core practicals that we are actually asked to do in physics, is to calculate this. Now, what about if we had a potato here? This potato, unfortunately, did get a little bit dunked earlier, so I'm just going to draw on his face again a little bit because we don't want him to lose his face. Now, what about if we wanted to work out the volume of this? Now, it would be more difficult because we couldn't actually. His face is on there. We couldn't do mass base times height times width. So what we do is we use a measuring cylinder. Now, I just grabbed a Pyrex jug from my kitchen, which has got the values milliliters and liters on the side. Now, if we wanted to work out the volume, we actually use a thing called displacement. Now, as we lower this potato into the water, it displaces the water. It moves it out the way. And it moves it out the way enough that actually, though it doesn't work, when I read it from the side, it's gone from being 200 centimeters cubed of water, 200 milliliters, to 300, which is useful for this potato because it's only 100. So we now know how much volume, how much space in a three-dimensional term, in a three-dimensional way, this potato takes up, because it moves that amount of water out the way and the water level increases. It raises up by the size of the potato. So we'll grab the potato back out again because we don't want him to drown, although he is a potato and potatoes don't drown because they're not a sentient being. So what we now know is that the potato, fortunately the potato has got its own back on my pen, and he messed my pen up. But anyway, we know that the potato the water level started off at 200 milliliters, it raised to 300 milliliters. We then know that the potato has a volume of 100 milliliters. And we know from up here that 1 milliliter is the same as 1 centimeter cubed. Therefore, it's 100 centimeters cubed of volume. Now, in terms, when we convert that into meters cubed, it actually takes up 0.0001 meters cubed of volume. So we know that this here potato takes up 0.0001 meters cubed, because a meter cubed is actually a huge amount of water. So if you think about it as in space, actually, if you got a meter cubed of water, it would weigh a ton. Its mass would be a ton. So the same as a small car. So you can see why this is such a small number, because actually in reality this potato is pretty small. He's just a little bit, about half the size of my hand. This guy obviously would have a slightly larger mass. So we have a mass of a volume of 0.001 meters cubed. Now we can then take the mass of this potato and we can go and calculate that. Now to get the mass, we just put it on a set of scales. Unfortunately, I do actually have a set of scales here. So here is my set of scales. It's a bit of a fancy old one, very old one actually. And it's got a bowl at this end, and then it's got another section where you put your weights and what happens, or your masses. And what happens is when your masses you put on this end are the same as on this end, they will balance. So this one here is 100 grams. I'm going to pop 100 grams on there. It hasn't done enough, but I've had a little look. Now, if I add on this, so this is actually a 1/4 ounce mass. But for this example, actually, if we convert it, it's about 7 grams, slightly more than 7 grams. It's rounded up at 7 grams. So what this means is that we've got 100 grams plus 7 grams. So we've got a mass of 107 grams. So our potato weighs 107 grams. That means its mass in kilograms, which is what we've got to convert it to, because that's our SI unit, is 0.107 kilograms. Okay, so we're nearly there on our calculation now. So let's get rid of this little bit here, because I've written down to the left that we've got our final numbers. So the final scores on the doors. So we've got a volume of 0.00001 meters cubed. That many noughts. I think I just said that many noughts. I hope so. And we know that we've got mass and we've got volume, and the mass is 0.107 kilograms. So what we need to do is do 0.107 divided by 0.0001. And that will give us our density. This gives us an answer of 1,070 kilograms per meter cubed. 1,070 kilograms per meter cubed. And that means that is our density. So really, the potato pretty much kind of has a very similar density to I don't know which way up he goes now. Oh, there he is. Has a pretty similar density to water. Water is pure water is 1,000 centimeters cubed. 1,000 kilograms per meter cubed. And salty water, seawater, is between 1,022 and 1,035 for the very, very high saline water. So it's slightly more than seawater, the density of a potato. Interesting facts that you can find out from working out the density of a potato, similar to water, which is not really that surprising, as it's made up quite a lot of water. So yeah, facts. Nice one.